Hello, welcome back. For this video we're going to discuss real numbers and exponents. We're going to do a little bit of simplifying and solving some simple expressions and equations. The first problem we have here is 3 raised to the square root of 2, which is a real number, times 3 raised to the square root of 2. Now the rule here is to add these together. Now when we have exponents that are square roots or cube roots or anything, we treat them like variables. So this is really like a variable in and a variable in. If we were to add them together, we would call it 2n. Therefore 3 to the square root of 2 plus square root of 2, which is the way we're supposed to handle the rule, that would give us 3 to the 2 square root of 2. There's a 1 out in front and a 1 out in front, and just like if I had 1n plus 1n, I would call that 2n. I wouldn't actually do anything with my variables. So we're going to leave the radical 2 as if it were a variable and call that 2 square root of 2. Now we can break this out, since that's multiplication. We can break it out into 3 to the second power 9, and we have a square root of 2 left over. So this ends up being our simplified answer for that problem. Here we have a power raised to a power. So 3 to the square root of 2 times the square root of 2. Square root of 2 times square root of 2 is going to give square root of 2 to the second power. And what happens is this 2 cancels with the radical, leaving 3 to the second power. And 3 to the second power is just 9. And the simplification of this problem is just 9. Now here's one we haven't practiced yet, but you have seen it in the rules. And then when you're doing division of exponents that have a like base, you can see they both have a base of 3. We're supposed to subtract the top expression from the bottom one, or we're supposed to subtract the top exponent from the bottom exponent. So the way we're going to do that is going to write it as 3 to the square root of 2 plus 2, that's the top one right here, minus, and you got to be careful, we're subtracting the entire expression, so that bottom one, which is square root of 2 minus 2, has to be inside parentheses. Keeping in mind this is like a negative 1, so if I were to distribute that negative 1 to both of those, I will now have 3 to the square root of 2 plus 2 minus the square root of 2, and then a negative times the negative 2 is going to give you a positive 2. So this comes down as negative and this comes down as positive because of the negative that was out in front. When you go to combine your like terms, you'll see that right here the square root of 2 minus the square root of 2 ends up canceling out. That ends up being 0. And then you've got a positive 2 plus 2, which is 4, so we have 3 to the 4th power. And 3 to the 4th power is going to end up giving you 81. So this entire expression up here simplifies to a simple numerical value of 81. Here we are again, like bases, multiplication. So our process is to add the exponents. So 7 to the square root of 3 plus the square root of 3. Remember, anytime it's under the radical, you're going to treat it like a variable. So square root of 3 plus square root of 3 is going to end up equaling 2 square root of 3. And then, of course, since this is multiplication between the 2 and the square root of 3, you can break it apart like this, just like it was a power raised to a power, going backwards. And we have 7 to the second power, which can be reduced to 49, and I still have a square root of 3 on the outside. So this expression is simplified. Same thing here. The only problem is this 49 on the bottom does not have a base of 7. So what we have to do is rewrite the whole problem. So 7 square root of 3 plus 2 over. Now I want to rewrite 49 with a base 7. So 7 to what power gives me 49? And it turns out it's 7 to the second power. Now that these two numbers have the same bases right here, we can just subtract their exponents. So 7 to the square root of 3 plus 2 minus, and since I only have a number 2 there, I don't have to put it in parentheses, it's just one term. So I have square root of 2 minus 2. So I have square root of 3 plus 2 minus 2. Well, these two will cancel out and give you a 0 and leave you with 7 square root of 3 as your final solution. Okay, the next one we have 10 to the power of pi and then raised to the power of 2. So power times a power, or power raised to a power, is a multiplication, so we're going to rewrite it as 10 to the 2 pi power. And again, since that is a multiplication, you can call that 10 to the second raised to the pi instead. You'll still get a 2 pi out of that, but 10 to the second can be simplified into 100 to the pi power. The square root of 6 to the 2 pi power. There we go. Yeah, this is actually a mistake here. So we're going to rewrite 6 to the 2 pi power, and we're going to raise it to the 1/2 power. So basically we're rewriting the square root as an exponent of 1/2. Now since I have a power raised to a power, I can multiply them. So I have 6 to the 2 times 1/2 times pi. Well, 2 times the 1/2 is going to give you 6 to the first power times pi, or just 6 to the pi power. And this ends up being the simplification of that number. Okay, for this problem, we're going to investigate something that we actually haven't talked about yet, and is how to simplify something under the radical sign. As you can see, we've got a square root of 2, a square root of 2, but over here we have a square root of 8, which, since we're supposed to treat those like variables, that is essentially two different variables. So what we're going to really do is take this square root of 8, and we're going to rewrite it as the square root of 4 times the square root of 2, because if I multiply those together, I still get the square root of 8. However, it turns out that the square root of 4 is equal to 2, and I still have a times square root of 2 underneath there. So I'm going to rewrite that problem with 5 square root of 2 times 5, and instead of putting square root of 8, I'm going to put what it's equivalent to, which is 2 square root of 2. Now I have all square roots of 2, and then on the bottom I have a 5 to the 3 square root of 2 property. Now I would go ahead and combine the top one. So 5 on the top, I have a times. So when I times, I'm supposed to add the exponents. So I have a 5 square root of 2 plus 2 square root of 2. Now remember, there's a 1 out in front, and that will become 5 to the and that will become 5 to the 3 square root of 2. And of course, on the bottom of this problem, I still have 5 3 square root of 2, so 5 to the 3 square root of 2 here. And you can see that the property here is to subtract. But any number divided by itself is going to equal 1. But we know this is going to equal 1. But I'm going to show you the process anyway. So it's going to be 5 to the 3 square root of 2 minus the denominator exponent, which is 3 square root of 2. And that's going to give us 5 to the 0 power. And anything to the 0 power, as we've already discussed, is going to equal 1. Here we're going to go ahead and solve an exponent. And we've got an 8 to the x power and a 2 to the first power. The problem with this is they both don't have like bases. So what we need to do is rewrite this one to have a base of 2. So we're going to go ahead and put a 2 to the first down here. Now we're going to leave the x on the outside, but we're going to call this 8. We're going to call it a 2. But what power do I have to raise that 2 to so that I get an 8 out of it? So 2 to what power gives me 8? Well, it turns out 2 to the third power. So this is really 2 to the third raised to the x, because 2 to the third is still equal to 8. And a power raised to a power means I'm going to have a multiplication. So this is going to be 2 to the 3 times x, or 3x power, is going to equal 2 to the first. And at this point we can see we have 2 powers on either side. They have like bases. So if the bases are the same or equal to each other, then we know that the exponents are also equal to each other. So in order to solve for x, we're going to bring 3x is equal to 1, which is the exponents. One exponent equals the other, and just solve for x. So we're going to divide both sides by 3, and we get an x equal to a 1/3 power. So back up here in the original, x is equal to a 1/3 power. The key here, however, is getting like bases. This one right here was an 8, and we had to turn it to a 2. On this problem, we have an issue in which we have a radical on the right-hand side. We can get rid of that radical by writing it as a 1/2 power, so we don't have a radical sign, or here's a simpler suggestion, just raise it to the second power. So the square root of 27, when you square it, ends up just being 27. But you got to remember, what you do to one side of the equation, you got to do the other. So over here, we got to raise this to the second power. So 3 to the x raised to the second gives you 3 to the 2x power. Now we can't solve this yet because we have a base of 3 on this side, and over here we have a base of 27 to the first. So what we need to do is take this 27 and rewrite it with a base of 3, just like this one over here. So bring that one down, 3 to the 2x, that's going to equal. So what do we have to raise this 3 to get 27? So 3 to what power equals 27? And as it turns out, it's 3 to the 3rd power. Now we have like bases that are equal to each other. That means the exponents, which is 2x, is going to equal the other exponent, which is 3. So these exponents end up equaling each other, and that's how we solve for x. So divide both those sides by 2, and we get x equals 3/2.